All right, so you know that feeling, right? You're staring at a big exam question, maybe one worth 8 marks, and you're just wondering, where do I even start? Well, you're in exactly the right place. Today, we're going to take apart a real GCSE computer science question, piece by piece, to show you how to think like an examiner and bag every single one of those marks.
So here's the game plan. We're going to start by unpacking the network challenge itself. Then we'll build the perfect answer step by step. We'll draw the diagram, compare star and mesh topologies, and absolutely nail the role of the switch. And stick around, because at the end, I'm going to give you a super useful exam-winning checklist that you can use for pretty much any question. First things first, let's get our heads around the scenario. Now, this is taken straight from the 2024 OCR computer science paper, so this is the real deal, exactly the kind of thing you can expect to see.
Okay, so this is our setup. Let's pull out the key info. We've got 5 computers, 2 printers, and 1 switch right in the middle. And the big clue for the layout, star topology. You have to spot every single one of these components before you even think about putting pen to paper. It's crucial.
That's the big question, isn't it? Well, this isn't just one giant task. It's actually broken down into 3 smaller, manageable parts, which all add up to those 8 marks. We're going to tackle them one by one and see exactly where and how you earn those points. Let's get into part 1, which is all about drawing a diagram. This is worth a solid 3 marks, and honestly, it's a fantastic way to pick up some quick points just by showing you understand the basic layout. Building this diagram is actually pretty straightforward if you just follow the steps. You know, in a star topology, everything revolves around that central device, so start by drawing the switch right in the middle. Then, just connect everything else, all 5 computers and those 2 printers, directly to it. But here's the golden rule, the one thing you absolutely cannot forget. You have to label everything. An unlabeled computer is just a box, and an unlabeled diagram is worth 0 marks. It's that simple. Now, this is where it gets interesting. We get to peek behind the curtain and see the examiner's actual checklists. This is literally from the mark scheme. So you get 1 mark for having all 8 devices drawn and clearly labeled. You get your second mark for making sure they're all connected directly to the switch and nowhere else. And that third mark? You get that for not drawing any extra random connections. See? It's just a case of following their rules. All right, on to part 2, which is worth 2 marks. For this, you need to compare the star topology we just drew with a mesh topology. All you need is 1 benefit and 1 drawback. And this slide lays out the killer points that are going to get you those marks. For the benefit, a really strong one is about reliability, right? If one computer's cable gets unplugged, the rest of the network doesn't even notice. It just keeps on working. For the drawback, the classic answer is its biggest weakness. If that central switch dies, the entire network is down. That's what you call a single point of failure. And using a key term like that, that's what shows the examiner you really know your stuff. Okay, let's lock in those final 3 marks. This last part of the question is all about describing the job of that switch in the middle of our network. So before we dive into its role, let's just quickly remember what a switch actually is. The easiest way to think about it is like an intelligent traffic cop for the network. It's not just shouting data out to everyone, it's smart. It knows exactly where each piece of information needs to go. So you want to know the secret to getting all 3 marks here? It's this exact 3-step process. First mark, you say the switch receives data. Second mark, you explain that it looks at the unique MAC address of the device the data is for. Think of it like a digital postcode for every device. And the third mark, that comes from saying it then directs the data only to that specific device. If you hit those keywords, receives data, MAC address, directs data, you're getting full marks, for sure. And just like that, we've done it. We've completely deconstructed that 8-mark question and figured out how to secure every point. Now let's zoom out a little and turn this into a powerful strategy you can use for pretty much any question they throw at you. This right here is your takeaway. First, always read the full scenario and pull out every single detail. Second, and I can't say this enough, label your diagrams. No labels equals no marks. Third, if a question is worth 3 marks, give 3 separate points. Fourth, use those official keywords you've been taught, like MAC address or single point of failure. And finally, always try to put yourself in the examiner's shoes. Ask yourself, what are they actually looking for me to write down? So here's something to think about. This whole method, breaking down the question, spotting keywords, and structuring your answer to match the marks available, it's not just for networks, is it? How could you use this exact same strategy for questions about the CPU, or cybersecurity, or even algorithms? Give it some thought.
Good luck with all your revision.